I need to take care of the most important part first, which is proving to my boss that I was actually here. So if I can get your picture, that would be great. If you want to smile or make funny faces, it's entirely up to you. Wave, yeah, that'd be good. Wave, everyone. So this is a great crowd. So, hey, starting off or close to starting off Java 1, everybody's still, awake and energized. That's good. As the week goes on, we'll see. But anyway, I do have stand-ins, so if my voice gives out halfway through, I can tag in a couple of people here in the audience, so you know who you are, and don't make a break for the exit. You're stuck. Welcome to this afternoon session on microservices minus the hype. How to build and why. It's more of a kind of a long-running discussion. We have about an hour here, which is just about enough time to touch on several subjects and not really to dive into any of them as well as any of us would like. But if we can get kind of things going and the thoughts going and the conversation going, that's great because we can carry on the good stuff later. My name is Mark Heckler. I am a principal technologist and developer advocate with Pivotal Software. You may have heard of Pivotal. They're the makers of Spring Boot, Spring Framework, Rabbit MQ, Redis, Greenplum, huge contributor to Apache Tomcat, a giant handful of other things. So we like to call it a small startup here in the Bay Area. So I blog, not as often as I'd like, but as often as I can at thehecklers.org, my private domain. I tweet all the time. I kind of live on Twitter, MKHeck. Is anybody here on Twitter? Oh, come on, that's it? Wow, okay. Well, for those of you who aren't on Twitter, I would recommend you get on Twitter, but other than that, I'm also a member of the slightly older and more established social network called email. So if you want to reach out to me, I'm far better at responding on Twitter because, again, I live on Twitter, but I do check email from time to time, so by all means, shoot me an email. We don't, again, have a lot of time. There's probably a good chance that I will cover something that you wanted to hear not at all, or that I don't cover it as well as you'd like. I gloss over it too quickly or whatever, and I'm happy to go into much deeper discussions about anything, spoken here or not. But, again, time. Excuse me. So, who am I? Well, I'm the author of several blogs and blog posts. I've co-authored one book already. I have another one in the pipeline. I've contributed to several others, both text and code. I love to read. I love to write. I love to share. I always feel like the more we all share, the faster we all learn, which seems like a net positive to me. I've spoken around the world on various development-centered topics. Thanks for inviting me back to Java 1. I've been here for several years, love Java 1. Always has a special place in my heart. First and foremost, I'm a developer. I use what works, and when I find something that works better, I adopt that. When I find gaps in something that is working, or maybe gaps in functionality that should be working, I try to fill those. I'm a Java champion, recently inducted, and very grateful for that because it's recognition by the community for contributions to the community. If any of you had anything to do with that, thank you. Really appreciate it. And as I say, I'm a survivor of many monoliths. I was a kind of a reluctant convert to microservices because I'd worked with monoliths for years. And I could see a lot of the pros and cons, but there's some comfort in what you know, right? So I didn't run to and embrace microservices, but I've come to be a convert, and I'll share some of the rationale behind that today as well. And like I say, I'm a seeker of a better way because I'm always looking for a better way to deploy real software into production, not undifferentiated heavy lifting, as Adrian Cockcroft, formerly of Netflix, likes to say. So anyway, so where do we go from here? Well, my goal today is this, to stay as close to a purely fact-based discussion as possible while hopefully throwing in numerous interesting or amusing TV or movie references at no extra charge. But no straw men. I always kind of hate it when people set up easy arguments and knock them down. Sometimes the arguments just kind of present themselves to you, but I really kind of hate to see when people take the cheap shots, so I try to avoid that. But I'm human. I have opinions. So if anybody's goal is to find something with which to disagree, I'm going to give you plenty to disagree with. That's cool. But let's talk about it. Let's talk after the fact and keep the discussion going, because I'm open. I'm learning. Everybody's always learning. So hopefully this talk is a thought-provoking, informative, and mildly entertaining talk. So this is the goal, not this. This talk isn't to impress, it's to inspire. Inspire to think, to consider, and to broaden our horizons a little bit. So again, to recap, the goal is this, not this. Okay, so I'm stepping away from the mic, and I can't do that. I love to walk around, and that's, unfortunately, if I walk around, you're never going to hear me today. So what is our goal as developers? Regardless of what you may have heard, speed isn't the goal, velocity is. Now, what's the difference, right? Well, get a little geeky here, spin my propeller. Speed is a scalar property. Velocity is a vector property. What does that mean? Well, the simplest way I like to put it is velocity is speed plus direction. So you can run really fast, and if you're running in place, you're getting nowhere. So a lot of the trade press and articles you read is speed is critical. Speed doesn't do anything. Velocity is what you need. You need speed in a given direction so you can make progress, and that's what we all hope to accomplish, right? So, one extra click required. So it's somewhat informative. Excuse me. It's somewhat informative if we're considering microservices to kind of know what we're considering them against, or in comparison to, and contrasting. So what are the alternatives? Well, typically, the alternative you typically hold up against microservices is this, the monolith. And as I say, that's one big app. Does anybody recognize this, by the way? I should have asked that earlier, but surely you all recognized the earlier two photos, right? Okay, good. I was starting to think maybe I was in the wrong room, the wrong conference. Does anyone recognize this? Okay. Do you know which Godzilla movie this was from, or show? What, I'm sorry? No, but no T-shirt for you. I'm just kidding. I don't have T-shirts. If I gave you a T-shirt, I'd be up here naked, and that's not anything anyone wants to see. So this is from the 2014 movie. So keep awake, folks. There's a quiz. Anyway, so I find it instructive when you're comparing. I'm going to try to move this a little closer. Apologies for any noise. I find it instructive when you're looking at something to try to define it, to look at its characteristics. So let's start with that. The characteristics of a monolith. Oh, okay. Yeah, I need to be able to see it too. Well, I can see that. Okay, that should work, right? Okay. Can you still hear me? No? Oh, come on. Everybody else said yes, but this guy, man. I'm the heckler in the room, okay? Keep that in mind. Okay, that is quieter, isn't it? Wow. All right, let's try that. I'll just have to look down here a little. Okay, so the characteristics of a monolith. Typically, you have one single logical executable. In the Java world, typically you're looking at a jar or a WAR file. God forbid, an EAR file, possibly even as well. But whether it's Java or something else, maybe a deployment bundle or a directory or what have you. So with a monolith, you have a lot of functionality cutting across several different domains, if you will, that are all bundled into a single logical executable. Typically, there's shared data across functionality. It doesn't necessarily mean a single database or schema, but that's usually the case. And that has a lot of history behind it. Typically what you see is organizations, wow, now I'm getting feedback. Okay, organizations where you have kind of a horizontal layering, right? So you have and it actually mirrors your organizations. Has anybody here heard of Conway's Law? Okay, excellent. Yeah, good, friendly crowd. Dr. Melvin Conway wrote back in the 60s. He's still active, by the way, prominent computer scientist, still tweets, although fairly irregularly. But he produced a paper in the late 60s talking about how your systems, any systems, will mirror the communication structures within an organization. You just can't help it. So typically when you have a dev group and an ops group, you have things that shake out like your dev environments and then your ops environments. And entering into the into the circumstances or the environment, the early days of computing where hardware and software were incredibly expensive. So you typically consolidated everything into a single database, into a single app server. And you tried to maximize that as much as you could. So you, over time, of course, things don't change in many cases. So many times still you have this monolith which has a lot of different functionality bundled into one logical executable, and you're running on a single shared data source underneath. It's just the way it has evolved over time. With a monolith, typically change to the flow of control without modification of the monolithic app is pretty near impossible. I mean, you're going to be doing some modifications, possibly to multiple modules within there, rebuilding the whole thing, retesting it, redeploying it. And I kind of actually got ahead of myself in the next point. Modifications to the monolithic application require the rebuild, retest, redeployment of the entire app. And there are tools to get around that, but they are indeed workarounds. I mean, they're excellent workarounds, but it's an acknowledged problem, right? Scaling the monolith requires scaling the entire monolith, including modules that you rarely use. I always like to kind of think of an order entry system or an online retailer system. And if an online retailer vets their customers really well, they may not have many returns. So the return module may be rarely used, but every time you have a change to your ordering system, you're going to rebuild everything, retest everything, redeploy everything if it is a monolith. With a monolith, typically, there's a greater attachment or a greater commitment to a particular set of technologies. There's a language, there's a platform like an application server, what have you, drivers, third-party libraries. And typically, these are somewhat problematic to employ. So once they're employed within any area within the monolith, that same library, that same deployment mechanism is used throughout. It kind of makes sense, especially when you're talking deployment. But even on libraries, typically if you bring in one library to do a particular function in one module, you're going to use that same library in all modules. It just makes sense. But that also increases your coupling to particular technologies across the board. There is a much lower cohesion and higher degree of coupling in a monolith. And this is something that's always troubled me a little bit. Because even if that's not the case initially, sometimes people make the argument that you don't need to break things out into microservices in order to have good design, and it's absolutely the case. But has anyone here heard of the second law of thermodynamics? Yeah, it's an unfortunate thing that things are going to devolve over time. The best example I can think of is if a junior programmer is on call, and it's, let's say it's 8 in the morning in California. Well, let's say better yet, it's earlier than that in the morning. And you're looking at the massive amount of people who are going to be coming online and hitting your site, hitting your application within a very short time. And the junior dev is told that the system's down and you need to get it back online. Now, let's say the junior dev really wants to do things the right way, but it's going to take probably several hours to figure out the right way to do it and do it in a way that's isolated and insulated from touching a lot of other things. Or there's a quick fix. But it involves reaching across several modules, maybe digging into 2 or 3 tables that aren't typically accessed from this particular module. But said dev can get this back online in 15 minutes. What do you think is going to happen? Because if that doesn't happen, if several hours go by and that system's offline, junior dev may be cleaning out junior dev's desk by lunchtime. So it's just a matter of practicality. Amazon is probably the best example I can think of for by pushing that and enforcing those boundaries, by creating everything in an API-first type of environment where you dictate that all business functionality has to be exposed via an API, and you have to maintain that API as a contract with other microservices. It allows you it enforces a certain rigor upon you. You can't reach in and access data that is controlled by another microservice because that's your only way in, right? So there is a much With a monolith, there is at least, even if not initially, eventually, a lower amount of cohesion, a higher degree of coupling across modules. Failure of the part usually equates to failure of the whole. Again, a great example of this is that data access layer, because if everything is using a shared data store underneath and that data store goes down, everything goes down. One huge benefit of a monolith is that the mental model is fairly complete for smaller systems. Meaning if you have a fairly self-contained, fairly small monolith, you can reason about the whole thing very well. And it's easier to kind of keep track of how everything is working and where all the bodies are buried, if you will. The problem with that typically is not initially, it's eventually, again. Because what typically happens, if you are told to develop a monolithic application and it's going to serve a work group or a small department, maybe even a division, what happens when your company buys another company? And this has never happened to any of us, right? Okay. Yeah, and then all of a sudden your 50 users went to 500 or 5,000 users, and maybe they were all in one location. Now they're geographically dispersed. What now? So this, the romantic concept of a very small self-contained monolith, I think in most cases, is just that. It certainly doesn't stay that way, even if it starts that way. So, in comparison, microservices. More than meets the eye, right? They come together, they accomplish a greater task. Does anyone recognize this? Okay, which year? Which movie? Yes, yeah. Oh, wow, okay, well, obviously there aren't any crazy movie geeks in here. I have another talk later this week where I throw out movie quotes, so, if you're really interested in, leveling up on your movie, come to that one. But this is from Transformers 2007. The subsequent movies weren't worth watching anyway, so, Okay. Cough break. All right, so some characteristics of microservices. Excuse me, don't want to go back a slide. Typically, microservices are independently deployable and executable services, multiples of them. They're focused services, very focused services in most cases. They provide specific application functionality. This allows you to develop in a way that makes sense for your organization, in a way that makes sense for your need, to provide velocity where needed and stability where not needed. Because again, there are going to be some modules, some business capabilities that are going to rarely change, that may be rarely used. So to focus, even in some tangential way, development resources on those is somewhat wasteful, right? So by breaking these down into focused services, you can focus upon what makes sense, what is more volatile, what needs to be given more attention and developed quickly or revised frequently. Control flow changes typically in a microservice architecture are trivial, certainly more trivial due to composition and queuing. You have a lot of things in play that can allow you to decouple things quite nicely and to, in effect, create new control flows without having to rebuild, I hate to say rebuild the monolith, but certainly rebuild massive amounts of functionality within your greater set of functionality. Typically, a change to any microservice is non-disruptive because, again, the smaller scope, adherence to that contract. If you change things internally, but you don't change the contract that you have with the outside world with other microservices, nobody cares. You're not impacting them. And typically, with the tooling that you have, the ability to swap in gradually or to do like blue-green deployments and things like that, nothing even has to notice, even consumers of your microservice. There's more effective and efficient scaling, as with velocity, in which we can develop and iterate quickly where needed. We can also scale what needs it when it needs it. So if there, does everybody know what Black Friday is? Okay, yeah, I mean, this is U.S., but sometimes you say that and people look at you really strangely. But with Black Friday, you may have to scale your order entry, your cataloging type of modules. You may not have to scale your returns module. Now, a week later, or maybe the week after Christmas, you may. But this allows you to scale what makes sense when it makes sense as well, and to scale dynamically up and down, so that you can concentrate your computing power where it needs to be when it needs to be there. Standardizing upon APIs and contracts for interaction provides opportunity for polyglot implementations, what I call polyglot plus. So you can choose the best fitting language, platform, locations. You can deploy things, some things on premises, some things in the public cloud. It gives you the opportunity to make those decisions at a much more granular level than a monolith could ever do. Much higher degree of cohesion and lower amount of coupling, because with bounded contexts, there's an API-enforced separation of concerns. Is anyone here familiar with domain-driven design? Dr. Eric Evans? Okay, bounded contexts. Single responsibility principle. You're looking at creating a microservice around a single responsibility. I always kind of find it a little ironic that single responsibility principle is do one thing and do it well. But anyway, some of you didn't get that. Ask your friends to explain. Anyway, sort of like the words hyphenated and non-hyphenated. That's a bit ironic, but okay. Anyway, so okay, we'll cover that later. So failure is isolated in a microservices environment. In a proper implementation, it anticipates failure, because in a microservices architecture, it's built around a different set of assumptions, if it's built right at all. In a monolithic environment, when the monolith goes down, the business stops, right? I mean, everything stops. And everything is focused, before that failure happens, on making sure that failure doesn't happen. With a microservices architecture, you typically assume failure, because Netflix. Anyone here is a Netflix subscriber? Yeah, a couple. So on the main page, that is all microservices driven, that single pane of glass, that single application. And would anybody hazard a guess on how many microservices feed that single pane of glass? Somebody? About 500, roughly. Last count, last I heard. So that's quite a handful, right? Now, how would anybody care to guess what the odds are that any one of those microservices is the only instance of that microservice running anywhere on the planet? Probably pretty low. So you have, let's just say for argument's sake, 500 microservices and 10 instances of each. That's easy math, so I'll take that. So that's 5,000 microservices that are having to run together and coordinate and communicate, right? Why do that? Well, because you know that you're going to have a certain amount of load capability. You also know that at some point you may have outages. You may have a network dropout. You may have an instance dropout, and that's fine, because you have a system built around the idea of failure versus the idea of, oh my God, I hope nothing fails. So it's built into the architecture. It's assumed. Let's see, so where did I leave off? Manageable mental model. This is something that seems a little contradictory from earlier, because with a small monolith, you have a very manageable mental model. But let's go to your typical monolith, where you have a rather large, sprawling system. And let's say you bring in a new developer, whether it's a junior dev or whether it's a senior dev from another department, another group. How long does it take them to get their arms around and build the mental model for that entire monolith? Forever, right? Whereas if you hand them responsibility for a small handful of microservices, I mean, typically you're looking at a small amount of code, a small amount of functionality. It's very easy to spin up very quickly in a microservices world. Jeff Bezos made the famous comment, 2 pizza box teams, and one of our engineers at Pivotal made the joke at a recent conference we had that we found that if you drop a couple pizza boxes into a room, then developers congregate naturally around them. I'm not sure that's how that works, but it sounds good, and pizza doesn't sound bad either, actually. But the idea is that it makes sense. You have a smaller amount of responsibility you can get your head around in Grok. So sometimes at this point in the conversation, people say, wait a minute, this sounds an awful lot like SOA. Isn't this just warmed over SOA? No. So moving on. You probably want a little more information, don't you? Okay, well, they're conceptually similar. And sometimes you hear the people say microservices is what SOA was intended to be. I think the implementation draws a really clear distinction. I throw out a couple of quotes and then we kind of dissect it a little bit here. I like what Martin Fowler says. Microservice style is very similar to SOA, but SOA means too many different things. And most of the time when we come across something called SOA, it's significantly different from the style that we're describing here. Usually due to a focus on what? On ESBs, Enterprise Service Buses. Used to integrate, and this is another thing that I absolutely love, used to integrate what? Monolithic applications. So SOA, even though a lot of people think that's just like microservices, well, no. It sounds like it at first glance, and then when you really kind of peel back the layers, you start to see that it's not really that similar. He also goes on to say that the fact that SOA means such different things means it's valuable to have a term that more crisply defines the architectural style. That's good, because we don't want one term that people interpret 100 different ways. Here they say microservices is an evolution of SOA concepts. The benefit that they bring, of course, is that traditional SOA is not speedy, it's not agile, it's very more difficult to make changes. And with microservices, the ability to make changes with less overall cost and less impact on the existing infrastructure is key, right? It's a different approach with different uses of technology. So let's peel back the layers a little bit. It was just taking too long, so I clicked. Unfortunately, it didn't like that. Wow, let's take our time. I guess I need to redo that slide. Okay, so SOA, what I call macroservices, right? Often they're monoliths retrofitted with service APIs and connected via a heavy, smart pipeline. So in a way, it's more complexity and even less nimble. Irony. It's also heavier. The protocol, the formatting of data exchange is heavier in general. You have SOAP, which makes no assumptions about underlying transport mechanisms. You have XML, which is a little more wordy. There's also more coupled ceremony because many, if not most times, producer and consumer code is generated from WSDL. So clients are tied rather forcefully to the API. And when the API changes, both backing services and clients must typically change in unison. Doesn't sound very decoupled, right? The Enterprise Service Bus products usually incorporate sophisticated facilities for message routing, coordination, transformation, and applying business rules. And as such, an ESB externalizes domain knowledge while incorporating process knowledge, which ironically increases coupling due to the aforementioned dumb endpoints while decreasing it because the bus orchestrates the processes. So it's kind of a mishmash there. All of these points and more make it much more difficult to scale within a SOA environment. With regard to microservices, the downside is there are a lot more of them. I mean, again, just in the little example I used for Netflix for a quote simple app, you're looking at thousands, at least thousands of instances of microservices. Microservices are lighter as a rule. They don't have to accommodate multiple transport mechanisms because guess what? HTTP won. So SOAP typically has things like, support for HTTP, SMTP, AMQP, UDP, what have you, versus REST over HTTP. Applications built from microservices aim to be as decoupled and cohesive as possible. Adhering to the API, the contract, is the only requirement for success. Changes to the microservice don't require synchronized updates as long as the API doesn't change. Ooh, I hear the difference here. I'll try to keep leaning in. A microservice owns its own domain logic, so you get the smarter endpoints. Typically, a microservice receives a request, takes the appropriate action, and returns a response. REST or similar versus something like WS Choreography or Beeple or other centralized orchestration tool. Pipelines, whether they're REST endpoint calls or message queues, are streamlined and straightforward, so they're dumb, so to speak. Decentralized and decoupled. I always kind of compare it like dancers versus an orchestra. If you consider SOA like an orchestra, anyone familiar with orchestras? Yeah, come on, right? You have a conductor right up in front. That conductor is really critical to the performance. And he practices with the orchestra, he or she. And at the time of the performance, guess where the conductor is? Right out in front, making sure everything goes right. Okay, let's compare that, our SOA orchestra, with our microservices dance team. So our dance troupe with microservices has a choreographer. The choreographer comes in and works with all of the individual dancers to make sure that they know what they're doing. So the dancers, in turn, when it comes to the night of performance, dance, they do their thing, they adjust to the dancers around them in case anything goes off, step. But where's the choreographer? Choreographer is either in the audience or maybe even in another city, maybe even halfway around the planet. The choreographer is not there. So the choreographer basically sets the situation up for success and then leaves. The choreographer is not the bottleneck in the situation, in the system. And that's kind of a key difference. So that's how I kind of think of it anyway. So microservices are built with scaling in mind from the beginning because they're smaller, they're lighter, they're bounded context, they're API driven. Again, if you adhere to the contract, everything's good. Excuse me. So there's always a gain, there's always a loss, right? And that's what it comes down to, is what are you willing to give up to get the benefits, if you are. And that's definitely the case. So let's take a look at a few of them. There are trade-offs. Some are somewhat contradictory. Welcome to the real world, depending on the priorities of the business. There's more scalability. Typically, you isolate high-demand modules. That gives you more focus. So you can scale those more readily. We've kind of talked about that. There's greater efficiency due to that increased focus. There's greater effectiveness typically because rapid iterations of what I call nuggets of functionality results in more accurate fulfillment of business requirements. If you're working on a module in a monolith, I always just like to ask this question. Don't embarrass yourself if you don't want to respond. But is anybody here working on a monolith or working in a group with a monolith, a pet monolith? Okay. What's your release cycle? Is it 12 months and up? Anybody? Okay, we got one honest person here. That's good. The rest of y'all, we'll talk later. 6 to 12 months? 3 to 6? 0 to 3? Okay, that's pretty good. I mean, you can have more rapid release cycles with monoliths. You run into a lot of friction. So typically what you see is longer release cycles, and many times there are really good reasons for that. There have been issues, there have been breakages, there have been a lot of things that contribute to all that. But what I always like to go back to is for your typical monolith, and I don't have the statistics right here in front of me, but a 12 to 18 month release cycle is not uncommon. It really isn't. So let's just say 12. That's easy, 1 year. If you're working on a 1 year release cycle and you're trying to get new functionality in there, if you're working with a business person or a business team to get new functionality in, how long does that take? Well, at the very least, let's say they got in early in your release cycle, and you've developed the requirement, you've worked up the code, you've gone through the whole thing, you've done the testing, the unit testing, integration testing, user acceptance testing, and all that stuff. Code freeze, deployment, everything's great. Minimum you're talking is a year. So what happens, has anybody here on a longer release cycle monolith ever had the case where your business point of contact, your subject matter expert, is no longer in that position at the time of the release? Yeah, and see, you're giving it away. You've all been there. And that frequently happens. That person is either in a different capacity, a different department, maybe even a different company. So what happens then when you release the functionality that you worked with Ann or Bob so hard to get in the system? Now all of a sudden Tony is taking over, and Tony looks at it and says, that's not what we need at all. Ann was high. Bob was always out to lunch. What are you doing? So then you get this, not that I've ever worked with Ann and Bob, of course, but so you get this problem with requirements drift, with not quite hitting the mark so many times. When you have greater velocity, you have a more bounded bit of functionality, you can release that rather quickly, right? So you can do a very quick release cycle. Maybe it's a matter of a couple months. Maybe it's a matter of a couple weeks. So the chances of losing that subject matter expert and losing that velocity, losing that accuracy is much, much lower. And as well as working more closely with them. So your misses are much smaller in a microservice world, all other things being equal. I kind of got off target there, but I mean, again, we've all lived through these things. That's why they're so funny, because we've all walked away and survived them somehow. Optimization. So let's see, you can choose the best language, platform, database for that particular service. And what's more, with a microservice, let's say that you adopt a particular bit of technology. You adopt a different language that maybe is more suitable for the statistics that's involved in this module, or a different database platform that's maybe better suited to how you're storing that particular data for that particular microservice. And let's say it doesn't work. Let's say that your performance is 1/3 of what it should be and you've eked out every bit you can. What then? Your risk is so low because you can rewrite the whole microservice in a very short time. You can't do that with a monolith. Your risk is dramatically higher just due to the size of it. And you'd never even consider a change in most cases of language or platform because it's just impractical. It just can't be done. Again, interoperability is higher because if you adhere to the API and access requirements, obviously you're in. Availability is non-binary. Architectures assume rapid multi-instance app deployments. Has anyone heard of the circuit breaker pattern? Circuit breaker capabilities. Your availability is typically much higher. On my talk later in the week, I actually show you that. I don't know that I'm going to have time to show you a lot of that now, but we'll touch on what we can. But the idea behind the circuit breaker, with a monolith, it's either up or down, typically, right? So if the monolith goes down, what happens? Well, demand doesn't stop. Demand just builds up. So when the monolith comes back online, what happens at that point? Well, here's your demand, here's your monolith. And that's what happens. So you get this weird situation of the monolith is up, the monolith is down, the monolith is up, the monolith is down. With a circuit breaker pattern properly implemented, as most microservices architectures incorporate from the get-go or very early on, you start restoring connectivity gradually. So it will occasionally, once every however many, it's typically very configurable, it will try to reach out to the down service and find it. And once it finds it, it doesn't just reroute all traffic to it, it gives it time to heal. So it will slowly restore that traffic and bring it back online to where you don't get into this whipsaw effect. So greater availability, greater independence. This is kind of fun to talk about here. But with microservices, you're typically not strapped to a particular platform or language. Again, we've mentioned that. You can develop certain microservices in one language or on a certain platform, different database, whatever, and not others. That gives you a lot of leverage. So you're not tied to a particular licensing agreement or a particular vendor. You have choices. You are in the driver's seat again versus what your acquisitions folks have told you you have to use because they signed a 3-year deal. There's typically cost savings, not out of the box, not out of the gate, not by default, but certainly the potential for cost savings. Because again, you're not tied to a vendor or a particular licensing strategy. You can choose what makes sense for you, technology-wise, license-wise, it's up to you. And potentially increased revenue. This is always a fun one to talk about because again, not out of the gate, not by default. But has anybody heard of Amazon? Yeah, a couple people, okay. Last year, Amazon's cloud revenues exceeded its revenues from all other business units, all others. Amazon is not a bookstore. Amazon is not an online retailer. Amazon is a cloud services company, web services, AWS, which kind of makes sense. But if you think about it, when it started, Jeff Bezos dictated that all services, and these were initially just to be exposed and used within the company, within the Earth's biggest bookstore, but all services would be, or all functionality would be exposed via services and controlled via access via API. So this became, over time, a very valuable contributor to revenue, a very valuable contributor to profits. So there's a very good chance that if you define an API, if you break things out more granularly, that you can create a better working environment for your systems internally, but also potentially expose more of those things to partners, to customers, and do so at a more granular level. Try that with a monolith, because you can do that, but you're going to be going to a lot of trouble to make sure that by exposing one bit of functionality within your monolith, you're not throwing out the keys to the kingdom. It's a lot more difficult, or potentially more difficult. At the microservice level, again, typically much less complexity because there's a shorter ramp up, easier knowledge transfers. And then, of course, control, see above. I didn't mention things like lower complexity per unit. Test cases are typically run only against targeted or changed modules. Faster deployments due to smaller apps/modules. Fewer tests for that particular module. Everything goes faster when you're having to test and code to this much functionality versus this much. So what are the losses? Those are all great things, but is it worth it? I don't want to give away the fun stuff. So let's see, what are the losses? Here we go. Well, there is a greater complexity at the macro level. Make no mistake, when you have 5,000 little bits of functionality running around out there, it's a lot harder to reason about for us. Typically, there are mechanisms put in place for microservices architecture that do two things, one of two things, sometimes both, but usually one of two. One is to make it easier for your microservices to interact and integrate, and the other is to make it easier for us to reason about them and keep control over them. A colleague of mine likes to call it the meatware. That's us. Sometimes you get dashboards and control consoles. That's for us. That's not for our services. They communicate over an API, but we have to understand it. So it's a lot more complex. Typically with a microservices architecture, you need better architects. Now, here's the key. You may have them already. They may be in your organization, but they're operating under the constraints you're giving them. So you may already have what you need, but you don't know that yet because they're dealing with an entirely different set of circumstances. Single data repository for the organization. You'll give that up with a pure microservices architecture. Most people freak out on that to start with. And I'll admit, I was one of them. That's something that nobody likes to lose control, right? And when you start having to look at, oh my gosh, if all these various microservices use different data stores, how do you get a view of your whole organization? How do you get an accurate view of what's going on? That's not so much of a concern, and I'll show you why momentarily. Change. Change is tough. Organizational change, architectural change, it's just not easy. And it sounds trite, but that's the toughest part. The people part is the toughest part. And then, of course, greater complexity. And I know I mentioned that up higher. It bears repeating. There's a lot greater complexity to a microservices architecture. And there's no such thing as a free lunch. There ain't no such thing as a free lunch, Tanstoffel. There are many advantages that it offers, but there are also drawbacks. So just be honest with yourself about that. So, has anyone heard of the Plato principle? Okay, now I'm really sad. Think of these, the various cans. You've heard of Plato, right? Well, I seriously, I've given this in Europe and different places. Plato's a big deal, and in other places it's non-existent. So it's cultural. Everything else, somebody asked me if I've heard of something, and if it's big in a particular place I haven't been to, I may not have. So, all kidding aside, Plato's a big deal. I like Plato. I still have a can sitting on my desk that occasionally I'll break out, and it's my thinking buddy. But think of these as bounded contexts, and they're bounded or separated by different color, right? So think of this as your monolith. Now, does anyone here have kids you've given Play-Doh to? Yeah. So you give them all of these colors, just beautiful. And in 30 minutes, that's what you have, right? It's, or better yet, this right over here. Yeah. How do you get that back? How do you separate the red, the blue, the yellow, the green? You don't, right? I mean, it's impossible. The Plato principle basically states that it's always easier to combine small self-contained code or data than it is to decouple code or to parse data. And you find that to be the case. I mean, instinctively, we know that when we think about it. It's just a discomforting feeling when we first start talking about this stuff. Does anybody here, I guess, is anybody here still using the single cross-cutting database underneath? A lot of you are. I know you are. I mean, even in organizations that are very forward-thinking, we still have some of those, right? So what do you do? I mean, you typically are on your production database that's cutting across various bits of functionality, that's covering the monolith, so to speak. What happens? You run everything off of it, right? Your productions run off of it, your backups, your reports. No, in most cases they're not, because you don't want to report to bring down your production database. You don't want to backup to bring down your production database. So what do? in most cases, you have some kind of a backup database, a secondary, a standby database that's sitting there running at all times, so you can offload those very critical bits of functionality, but they're not critical to production. This is really no different. You have a little bit different way of implementing it with microservices, but you can have event sourcing. That's a very important topic. In fact, one of my colleagues is going to be speaking with Chris Richardson about that at some point this week. I have to check the schedule. But I would encourage you to take in that session, Kenny Bastani and Chris Richardson. I think they're going to be covering that very nicely. But at some level, in some mechanism, you're going to need to maybe consolidate or offload some of that, I say offload, duplicate some of that data in another store that's not your production set of microservice data stores. It's very similar to the pattern that you're already employing for your monolith. So you really don't lose anything. It's just a slightly different implementation. That's why I say it's not really so much to freak out because you don't have a single source of truth. You always will have a single source of truth in some way, shape, or form. So what do I need to execute? How much time do we have here? We have probably enough time to actually discuss some of the concepts and maybe show a little bit of code. But again, I would rather be clearer and cover this much than unclear and cover this. So let's charge forward and see how far we get. And again, by all means, ping me afterward and we'll continue the discussion. So, a very simple example. You remember earlier I mentioned that in any type of microservices architecture, you'll typically have some enabling services or enabling constructs. And some of these are enabling for your microservices, some of these are enabling for us, for the meatware. So if you have, going back to the Netflix example, where you have 5,000 instances of various microservices, I guess stepping back just a moment, has anyone heard of the 12-factor app or the 12-factor manifesto? These are, I feel like I'm throwing out a lot of stuff at you. I have notes. If you want to, please do, look up some of these things if you're not familiar with them already, and if you are, please revisit them. Typically good architecture, especially when you're deploying to cloud environments, as we're all increasingly doing in some way, shape, or form, or will be if you're not now. You typically look at certain patterns that make your life easier, that make your code better. So I always kind of pull out a couple of those as the big hitters. You want to externalize your config, because if you have your code littered with configuration, that creates problems in several ways. One, if a backing service changes its location, then you have to go in and rebuild your code. That's not fun. That's not nimble. That's not agile. So you have to rebuild your code, retest, redeploy, and if you have a system outage, that's a horrible thing. So you want to externalize that. You also, for security reasons, want to do that. Kind of the litmus test is if your boss came to you and said, we need to open source our software today, this afternoon, the big boss made the decision, it's out of my hands, just do it. Could you do that without exposing credentials? Could you check all your code into GitHub without exposing credentials and risking your business? Most of the time, that's not the case. But if you externalize that configuration, and config is basically what? It's key value pairs, if you break it down to the simplest mechanism. You have something that says, go here, and that's your database service, your backing service for your data. Go here, and this is where to find some other public API you're going to call, some other endpoint. So by externalizing all of this, you make your code very tight, very versatile, very portable, so you can deploy that in a different location. And as long as you provide those variables, it doesn't matter. It can run on anything, anywhere. So by doing that, though, when you get into microservices world, you start talking about, if you had one monolith that was pulling a few properties from your environment, that's one thing. That's not that hard. But if you have 5,000 different instances of microservices and you're having them go out and forage about for their configuration, that gets to be a little harder to manage. So we need something that brings those into a manageable, centralized location without inserting a new bottleneck. I always go back to the Spring Cloud OSS and Netflix OSS because, hey, I work for Pivotal, and Pivotal has a great relationship with Netflix. But all this stuff that I talk about is open source, and there are multiple other options out there, not ours. So do yourself a favor and please just look them up and see what works for you and makes sense. But with a config service, typically you store your configuration settings somewhere and serve them up to your various instances of microservices. So you can still manage them and maintain them and provide them. You can also refresh your various microservices via things like Spring Cloud Bus or some other mechanism that says, hey, updated config, go out and get it. So you don't have this giant push. Again, no new bottlenecks you're inserting. Typically with the config service, it rests on something like Git or SVN because, hey, we use that stuff all the time to handle code, well, text, which code is text, right? Well, so are properties. No big difference. So you have your auditing and your version controlling and all that stuff built in. So typically there's some kind of a config service. There's also some kind of a service registry. I always look at this like a phone book. Is anyone here familiar with the antique concept of a phone book? Yeah, I mean anymore we just grab our phone and say, call Bob. But in the old days, when you go to a new city, you'd find this silver box in the corner, hopefully. And hopefully you'd pop open hopefully there'd be a book attached to the chain. Sometimes there was just a chain dangling there. But, you know, hopefully there's a book there and it has the pages and you can find Bob and then you look up Bob's number and call him. Your microservices need something similar. They need a service registry, a place to see and be seen. That's really critical in the ephemeral world of microservices because if I have an instance of a service running here and it dies or the network connectivity is lost, your platform typically is responsible for maintaining a fixed number of those based on demand, based on numbers, whatever. So if this one dies, it may spin up another instance over here. How is that instance found by consuming microservices? Well, that's why you need a service registry. So that needs to be implemented in some way. I actually throw in a couple of things here very simply, which is a quote service, a backing service. This is a database-enabled service that allows me, again, I'm a movie and TV fan, so I store movie and TV quotes and pull those up and provide those as a backing service to an edge service, which then can be accessed via mobile phones or whatever. And then, of course, mentioning the circuit breaker pattern earlier, Hystrix is Netflix OSS's entry into that environment for circuit breakers. And that allows me or my edge service to continue functioning and provide, again, default values or some other value if the backing service is offline. Hystrix in particular is really nice because it lets you stack several or chain several different fallbacks. So you know it's turtles all the way down until you get to where you just go, I give up, here's some, here's an empty set or whatever you want to do. But it gives you options to fall back. Really quick overview of those. Your config service, again, you have a Git repository. You can push updates. You can notify your various instances. They'll go out and pull refresh config. I'll leave that up just a minute here. And then for service discovery, you have things like Netflix Eureka. Eureka is actually good for a lot of other things as well. Netflix uses it extensively. But I typically, in my examples, use it just for the service registry and discovery capability. But each different producer registers with the registry. All that information, by the way, and this is kind of critical when you're talking about the microservices, again, no new bottlenecks, right? So if that goes offline, you want all of your consuming microservices to have cached that information. I mean, typically you still, implement it in a high availability type of situation where you don't just have a single service registry running, instance of it running, but let's say everything just, falls on the floor. Your other microservices should still have that information cached and be able to reach out to their backing services. And then at some point, when your service registry comes back online, they reestablish and refresh. Same with the config server. With a client-side load balancer, and it's client-side, again, client-side meaning your client, you're consuming microservices. There's a load balancing that goes on. You don't insert a new bottleneck for your backing services because typically with your load balancers, on the back end, that if something goes down behind them, they may not necessarily know. They're just funneling traffic. If that goes down, you can't get to your services behind there. Whereas a client-side load balancer, again, you have that cached. So it's very much more survivable. And with the intelligent router, sometimes you have people ask, how do I get away from my monolith if I'm looking to migrate from that? You may have heard of the strangling the monolith expression. With intelligent routing, you can define routes outside of your software, outside of your monolith, outside of your microservices that are then employed to route traffic, to route calls, still to your monolith, but over time as you build out your microservices portfolio to reroute those without having to change the code. Quick look at the circuit breaker. Again, typically with your circuit breaker, you have an open or closed status, but you also have a half open status so it doesn't immediately slam it with traffic when it's coming back online. It gives it time to heal properly, so that it doesn't get into the whipsaw effect of a monolith. And then there's typically some kind of a circuit breaker dashboard so that you can see what's going on with your various edge services, your backing services. This is for us. This has nothing to do for our microservices. This is just for us to see and understand what's going on behind the scenes, so we can see when something's down. We can see when it's coming back online. So I actually don't have, I just have a couple of minutes, so I don't really have any time to launch into code. So what I'll probably do is just kind of wrap up here and then field a couple questions, and then we can take it offline, ping me afterward. This is Adrian Cockcroft. He just spoke a couple months ago in Vegas at our conference, and he made the comment I thought was really good, because I've said this, but of course it means a lot more from him. Monolithic apps only look simple from the outside, and anybody who's worked on them knows that's the case. I mean, it's very simple to reason about when it's one big thing. It's just when you get in and try to peer under the covers that it scares you. Microservices enforce separation that makes them less complicated. And again, the argument is you can make a very structured monolith to where it's not as complicated, but it never stays that way. I mean, even in the best of hands, it just can't. It's the world we live in. So with that, I guess I will stop talking, and I'll throw this out there. These are just some points. Typically, the examples that I go through, and again, later this week I have another session where I actually do pretty much full live coding, and I use a lot of these things. My repo's down at the bottom. I do have slides and materials and stuff out there as well. But MKHack on Twitter, that's the best way to reach me if you have any questions, comments. If I glossed over something too quickly that you wanted to hear more about, again, happy to discuss it at length. So any questions? Yes? The question was, how about the added latency? That can be an issue. All kidding aside, that can be an issue. Typically, and you have certain things that are different architectural styles that are being implemented, or different solutions that are coming to bear on that now. What I always kind of go back to is that in most cases, your simple HTTP REST is not a problem. In most cases. We always worry about that because, of course, we're trained and we're experienced in trying to expect the worst. But in most cases, it's not a problem. Now, how do you know if it is? And that's where you get tools like Zipkin, where you can do network tracing across your various microservices, which also makes you ask, okay, or somebody will ask, well, then that adds some overhead. Well, that's why you have to have a good set of tools that add minimal overhead while giving you as much information as possible, similar to the profiling tools that are built in and baked into the JVM. With Zipkin or things like it, you can trace, you create a trace or follow a trace throughout communication across various microservices in your system. And then you can have spans within that. So you can establish your baseline to see, okay, is 2 milliseconds okay for this, or is that large? Is 200 milliseconds okay for this, or is it large? And it allows you to establish a baseline so that you can determine what the problem is. In a lot of cases, and we've all seen this too, it's not so much a problem of you create new problems, but you're able to find them that you couldn't have found as easily before. So even though you're talking some out-of-process communication, you can also maybe establish some networking issues that you didn't realize were there sometimes, ironically. So, yes?
How can you maintain a transaction across several microservice calls?
Aha, glad you asked. The question was, how do you handle transactions? There are ways you can do like distributed transactions, but typically what you learn to embrace is your eventual consistency. That always makes people a little uncomfortable. It made me uncomfortable. I always used to kind of have the saying, eventual consistency means inconsistency. And that is true at its very highest level. But I always kind of go back to the model for banks and ATMs. And a lot of banks use eventual consistency. They don't use distributed transactions. And that's because the cost is so high for the risk involved. If you have an ATM and your wife has an ATM, and the odds of you withdrawing $1,000 cash on opposite sides of town at the same exact instant instant are pretty slim, or within a few seconds. Again, really slim. So what typically happens is they accept a certain degree of eventual consistency, knowing that the odds of that being gamed, being played, are pretty low. But it allows you also to be very agile in terms of responsiveness, very responsive in your system. So you don't have to wait for a transaction to go through all of the various hoops before you issue the cash. And there are many other transactions where that's just a killer. You can't wait for several seconds or minutes for a transaction to complete, even if you could, extend the timeouts that far. Practically, your customers would never tolerate it. So again, it's kind of a different way of looking at it. You can, with microservices, do distributed transactions. It's just really typically not recommended you do, because you get into the thing of if this fails, and how do you get that back? Because they're operating independently of each other, not just down a chain, but independently entirely. So different can of worms, but very achievable if you change the way you're architecting your system. So yes, I'll take one more really quickly.
How would you handle a requirement to paginate and sort data across multiple microservices?
To paginate? Oh, wow, sorry.
Paginate and sort.
Typically what you'd have to do is in a case like that, where I mentioned you'd have some kind of a collector where you create an external store that aggregates that data in some meaningful way. You typically wouldn't go out and hit your various production microservices and assemble it yourself. You could, but in many cases you're also creating that secondary data store anyway. So I would point you to that as your source of truth for reporting and things like that. That would give you, that completely avoids having to go out and ping everyone individually. The work is already done for you. So, all right, everybody again, please follow me on Twitter, email me, whatever, it's all good. Happy to talk about this at length, but thank you for attending. Thanks.